Hey everybody, this is McGuire, and you're watching a video about projectile motion. A projectile is any object that is only experiencing the force of gravity. So it's basically the same thing as a freely falling object. The difference usually is that it's moving sideways as well as moving up and down. Here we have two examples of what people generally think of as projectiles, a missile and a bullet. But in this case, the missile is not a projectile. The reason being, it's experiencing the force of gravity because it's on Earth, but due to the thrust coming out of the back of the missile, that creates an additional force that actually combats gravity. In the case of the bullet, the only force acting on it is gravity. As you can see in the picture, there's a lot of air drag going on, but if you ignore air resistance, like we do in most physics problems, most high school physics problems, if you ignore air resistance, the only force left is gravity. And in fact, if you fire it on the moon, there would be no air to begin with, and no air resistance at all. So that's the basic idea. A projectile is something that's only experiencing gravity. It's basically moving through the air. So let's look at a couple things that relate to that. A couple important facts for projectile motion. First of all, these are some things you'll have to memorize. First, X motion and Y motion are totally independent. X motion and Y motion are independent of one another. You can see this example in your car. If you're riding in a car at a constant velocity and you throw a ball up in the air, you'll find that the ball falls right back in your hand. That's because the upward force that you give the ball doesn't make it change its X motion. If you're moving at 40 miles per hour in your car, you're moving that speed, the car is moving at that speed, and so is the ball. So when you throw it up in the air, it doesn't slow down in the X direction. It maintains that 40 mile per hour speed in the car. So that's the next point. X velocity always remains constant. X velocity remains constant if you ignore air drag. In the case of this bullet, of course the air drag would slow it down and keep it from moving as fast in the X direction. But if you ignore air resistance, which we'll do in this case, there's no force to slow the X motion down. So X velocity will stay constant. And third, Y velocity changes by negative 9.8 meters per second squared. So since it's in the gravitational field, it's going to experience the acceleration due to gravity. So since we have these two motions, we have the X motion of an object, and we have the Y motion of an object, we have to have separate equations for each of these. So we can go up here and look at them. Here's the original kinematic equations. In the case of the Y motion of the object, we'll just plug in all of our Y information. For example, on equation 2, our change in X becomes change in Y, our V final becomes Vy final, our V initial becomes Vy initial. Another important thing is that for all of these accelerations, you can go ahead and plug in negative 9.8 for all those, because assuming it's on Earth, it's going to accelerate at that rate. So those equations aren't going to change. Bruh. Okay, that'll work. Bruh. Doing it live. Okay, so in the case of the X equations, we're going to plug in 0 for all those accelerations. The reason being, well, our X velocity is not changing. So our X velocity is going to be 0. So all of these terms that have acceleration in them are going to totally cancel out. So for our x motion, we're only left with one useful equation. It's going to be this one right here. That's going to be our final equation for the x motion. So where we get the equations isn't as important as having them to begin with. So I'm just going to write down the equations. I'm going to do it on a different page because I'm having trouble here. So here's our equations. Equations for projectiles. Equations for projectiles. In the x motion, we only have one equation. And that seems like it's kind of daunting because we only have one way to get our answers, but that's actually great because if I want change in x, I must have vx and vt. I want vx, I must have x and t in order to get it. So it's pretty easy to figure out whether or not the problem is solvable. In the y direction, we have 4 equations still. Here's our first one. Change in y equals vy initial times time plus 1/2 ay t squared. So I took the old equation and just put some y's on it. Next one, change in y equals vy initial plus vy final over 2, and that whole thing will be multiplied by t. You can put parentheses there if that's easier for you. Third, vy final equals vy initial plus ayt. And finally, vy final squared equals vy initial squared plus 2ay changed in y. So it's the same old equations with just a little extra. So that's it. Those are the equations. Let's actually use them for something now. Here's our one example. Example 1 of 1. We're just going to have a ball being kicked off of a cliff. So the classic example of this problem is a cannon fired horizontally or a ball kicked horizontally. We're going to go with the soccer ball. So here it is. A ball is kicked off of a 100-meter cliff with a speed of 18 meters per second. I'm going to add something there that I forgot. Horizontal. So it's kicked horizontally. Let's try it. Oh, we need the question too. Determine how far away from the cliff it will land. So here's the scenario. We got a ball being kicked off of a cliff. It'll go like this, land on the ground, and we want to know this distance right here. But we know a couple things. First of all, it starts out with that horizontal velocity of 18. The cliff has a height of 100. And something that's noteworthy, when we hit the ground, we still have a horizontal speed of 18 meters per second. The only difference is that we also have a vertical speed on top of it. So there's our setup. So in order to solve any problem, you got to figure out what your givens are. First, start with what they're asking you for. They want to know what is the question. They want to know what is that horizontal distance that it travels. So we call this displacement. And in projectile motion, you want to differentiate between those x's and those y's. Since it's horizontal, we're going to call it change in x as opposed to change in y. Change in y will be 100 meters because it falls down 100 meters. We need to be more specific though. That's negative 100 meters. They still gave us a bunch more info. That horizontal velocity will be Vx, 18 meters per second. As usual, since it's flying through the air, Ay is negative 9.8 meters per second squared. And the tricky part is the y velocity. At the end here, we do have a y velocity. It's definitely moving down. But right at the beginning, we have no y velocity. The object doesn't start moving down until a split second after it leaves. Until right here. It's going to be moving down a little bit, with a little bit of speed. So not until gravity takes hold on it and pulls it and accelerates it, it's not going to be moving at all. So that's huge. For any horizontally fired projectile, Vy initial is going to be 0 meters per second. So here's the deal. Here's the deal. If you want to change an x, there's only one equation to get it. And that's this guy. We need Vx and we need t in order to solve it. We have Vx, but we don't have t. So we're going to solve that. We're going to solve for t using the y equations. So the only variable that these x and y equations have in common, the only variable they have in common is time. You can find time from either the left side or the right side and plug it in to the opposite side in order to find out information. So time is huge. It's the link between the two. So we'll find time and solve the answer using our y stuff. The only equation that's solvable using our y information and in looking for time will be this one. I haven't memorized it. What am I looking at? It'll be this one. So we'll plug everything in. Negative 100 equals 0 times time plus, I missed my 1/2. 1/2 negative 9.8 t squared. Fortunately for us, the 0 cancels out, so we don't have to use the quadratic equation to solve for t. Next line down, I have negative 100 equals negative 4.9 t squared. To solve for that, divide by negative 4.9. We're left with negative 1. Ooh, we're left with 20.4 equals t squared. And lastly, you square root both sides in order to get your time. I'll choose the positive answer because time can't be negative. So we have the time it takes for the ball to fall down. It takes 4.5 seconds for the ball to fall all the way down. And that's the amount of time it travels horizontally too. So we can plug that 4.5 in right here. Change in x equals 18 times 4.5. And we'll get our final answer of 81 meters. So that's it. Just keep in mind with projectile motion that you got to keep your x values and your y values separate. Your x velocity never changes, and your y velocity is always changing at a rate of negative 9.8 meters per second squared. Lastly, time is the link between these two equations. If you have some y information and you need to find an x variable, you can find the time using the y information, plug it in, and vice versa. If you only have x information, like if you have change in x, but you don't have, you have vx, you can find time and put it into your y equation. So that's it. Good luck.